y to x is called as converse of relation R. In short, just we have to alter the sequence of order pair or elements of order pair. Then it will give you converse of that relation. If relation R is from x to y, then we can say that converse of that relation, that is defined by this symbol. This is R converse. That R converse is from y to x. And how to obtain it? So here, in order to obtain R converse, we have to interchange the members in each and every order pair of R. For example, if your relation R is containing any order pair 1, 2, then R converse for same relation is order pair 2, 1. So what we did here, just we have interchanged the members of order pair. That is called as R converse. Okay. Have you understood what is meaning of converse of relation R?
Repeat, ma'am.
Okay. So suppose any relation R and that is defined on two sets x and y. So we can say that a relation R is from x to y. Okay. Now if you want to find the converse of that relation, then the converse will be from y to x. Okay. So now suppose your relation R is containing one order pair 1, 2. Now, how to obtain R converse? So, that is obtained by interchanging the sequence of elements in order pair. Now, R is containing order pair 1, 2. So, here 1 is the first element, 2 is the second element. So, in order to obtain converse of this relation, we have to interchange the sequence of that those elements, that is 2, 1. Okay. So here 2 is the first element, 1 is a second element. Just we have interchanged the elements in relation R. So here is R converse. Meaning समजलं का? जर R मध्ये ऑर्डर पेअर 1, 2 असेल तर R कॉन्व्हर्स मध्ये ती 2, 1 असणार आहे. फक्त सिक्वेन्स चेंज करायचे एलिमेंट्स. Understood now?
Yes, ma'am.
So here again R converse this is equals to R. So this is same as the negation that we have seen in the first chapter. Negation of any variable, that will give you original variable. Like negation of negation P, that is equals to P. That negation gets cancelled. Likewise converse get cancelled and you will get relation R only. The relation matrix M of R converse can be obtained by simply interchanging the rows and columns of MR. So last lecture we have seen what is the MR, that is relation matrix for any relation. So matrix drawn for any relation is called as matrix or a relation matrix, and that is denoted by MR, where M is for matrix, R is for relation R. Now, if MR is given, then how to find MR converse? So, we can find it by just interchanging rows and columns. So, rows will be replaced by columns and columns will be replaced by rows. So, that is called as matrix for R converse. Okay. So, we are going to solve some examples based on this. So, you will get clear idea. Here MR converse is equals to transpose of MR. Okay, so why we have written this statement? Because just now we have seen MR converse is obtained by interchanging rows and columns of MR. So when you are going to replace rows by columns and columns by rows, it is called as transpose of MR. Okay. That's why M of R converse is equals to transpose of MR. Okay. Then the graph of R converse is also obtained from R by simply reversing arrows on each R. Yes. If graph is given for relation R, then we can obtain the graph for R converse. How? Just we have to change direction of each and every arrow in that graph. So it will give you graph for R converse. Okay. So here we have seen if relation R is given, how to find R converse. Okay. So that can be found by interchanging sequence of elements in each and every order pair. That is the first point. Second point, if matrix for relation R is given, then we can find matrix for R converse. How? Just interchanging rows and columns. And third, if graph for R is given, then we can find graph for R converse by just changing direction of arrows in on each and every arc. So these are the some points related to converse of R. Have you understood? After this we are going to solve some examples based on these. मीनिंग तर समजलं का? आर कॉन्व्हर्स म्हणजे काय?
Yes, ma'am.
Yeah.
Yes, ma'am.
Now here one formula is given, converse of composite relation. Now what is the composition? We are going to see in the next point. So here just they have given one formula. So take note of this. R composition converse S is this is equals to S converse composition R converse. Okay. So I think you should take note of this. What is the converse of R? How to obtain matrix for converse relation, and third one, how to obtain graph for converse relation. So first of all, take note of these 3 points. Then we will solve some examples. Take 2 minutes and just note what is the converse relation, how to obtain matrix for converse relation, and how to find graph of converse relation. Okay, so now we are going to solve some examples. Question number 1. Given the relation matrices MR and MS, find MR composition as MR converse, MS converse, MR composition converse S, and show that. So now here we have to prove this formula. The matrix for R composition is this is equals to matrix for S converse composition R converse. Okay, so one by one we are going to solve all these problems. So MR. So what is meaning of this MR? This is a matrix for relation R. MS means what? Matrix for relation S. Okay. So first of all we have to find what is MR, that is matrix for R converse S. Okay. So first we will see how to find R converse S, and that is simply obtained by matrix multiplication. So can anybody tell me what is the matrix multiplication of R and S? So here matrix for R and S are given. So we have to find what is the matrix multiplication of these two matrices. Can you tell me how to find matrix multiplication? What is the way? Okay, so first of all tell me what is the resultant matrix here. First matrix is 3 by 3, second one is 3 by 5. So what is the resultant matrix?
3/5.
3 by 5, yeah, correct. So here we have to perform matrix multiplication. That's why consider first row and first column of relation S. Okay. So first row of R is 101 and here first column is 110. So what is the final value? 1 into 1, that is 1. So first value for this R composition S is 1 here. Okay. Now again first row second column, so 0 0 1. Okay, how to find this? First find 1 into 0, that is 0, plus 0 into 0, that is again 0, and plus 1 into 1. So final value for this multiplication is 1. So that we have to write here. Now again first row third column, so 0 0 0. So it will give you 0 only, and that is written here. Again first row fourth column, so 1 0 1. So again its final value is 1. So here I have written 1. And then next one, first row last column, that is 0 0 and again it is 0. So that is written here. So likewise we have to find matrix multiplication. So this is the answer for matrix of R composition S. So again we have to take second row and first column here. So second row is 110, first column is 110. So answer is 1 into 1, it is 1. So once we will get 1 1, then we have to write that 1 here. So I have written 1 here. Now again second row second column, that is 0 0 0. So final value is 0. Again next one, second row third column, and that is 1 into 0 0, 1 into 1 1. So write that 1 at this place. Again second row fourth column, so 1 into 1 1. So its final value is 1. Then second row last column, again its final value is 1. So here your second row in R composition is 1 0 1 1 1. Likewise we have to take now third row first column. So third row is 1 1 1 and first column for S is 1 1 0. So first value is 1. Now check for second value. What will be the second value?
1,
1. Okay. Third value?
1,
1. Fourth value? 1. And last one?
1.
1. So all the values in the third row, it is 1, 1, 1, 1. Okay. So this is the matrix for R composition S. So whenever you have to find matrix for any two relation composition, then you have to find matrix multiplication. Okay. So this is the answer for our first point, matrix for R composition S. Now second question they have asked, what is the matrix for R converse? So here we have seen how to find matrix of R converse if matrix of R is given. So just we have to interchange rows and columns of matrix of R. Okay. So M of R, that is matrix of R is given. From this we have to find matrix for R converse. That's why we have to just interchange rows and columns. Now if you observe here, 101 is the row of MR. Now in order to find MR converse, we have to take 101 as first column. Okay, so now take here 101 as first column, then 110 is the second row in M of R. So here we have to consider this one as second column in M of R converse, that is 110. And 111, this is the third row. Now we have to consider this one as third column in M of R converse. So this is the way to obtain M of R converse if M of R is given. Just we have interchanged rows and columns. Have you understood? Hello?
Yes, ma'am.
Okay. So now we have to find what is the matrix for S converse. Matrix for S is given. From that you have to obtain matrix for S converse. S. What will be the first column?
10010.
S. First row becomes first column. Then second column,
10101.
yes. And third column,
01010.
yes. So this is the answer for M of S converse. Now, next one they have asked matrix for R converse composition converse S. So first we have find here what is the matrix for R composition S. So how to find matrix for R converse S, that is composition converse. So again same strategy we have to follow, just convert rows into columns and columns into rows. Now here 11010, this is the first row. So we have to take this one as first column. That's why I have written here 11010 as a first column. Now second row is 10111. Now I have to mark this one as a second column, that is 10111. And last row is all ones. Now we have to consider this row as last column, that is 11111. Just I have interchanged rows and columns. Okay. Now what they have asked, we have to show matrix for R composition converse S. This is equals to matrix for S converse composition R converse. Okay. So we have find what is the answer for matrix of R composition converse S, that is given here. Now find matrix for S converse and R converse. We have to take its composition. So can anybody tell me how to find this value? Matrix for S converse, composition R converse.
By matrix multiplication.
Yes, by matrix multiplication. So that's why first of all we must know what is the matrix of S converse that we have to take by just interchanging rows and columns of matrix of S that we have obtained here. Again, matrix for R converse, that is also with us, that is M of R converse. Now just you have to perform matrix multiplication between these two matrices, M of S converse and M of R converse. Now check here, first row is 110 and first column is 101. So what would be the value for final matrix? Can array, it is 1. Again, first row, that is 110 and second column 110. Again its value is 1. That is given here, 1 1, first two values. Again third value. So again consider the first row in M of S converse and last column in M of R converse. Again it is 1 1 1. So final value is 1. So likewise you have to perform matrix multiplication in order to obtain composition if matrices are given. Okay. Now check here. If you solve this, you will get same answer. So matrix for R composition converse is, it is given here. That is where I find it out. Now here matrix for S composition, S converse, composition R converse. If you check all the values, you will get these two matrices are same. That's why we have written this formula as R composition converse is, this is equals to S converse composition R converse, or we can say that matrix of R composition converse is, this is equals to matrix of S converse composition R converse. So in this way we can prove this last statement. Now tell me, how do you have understood all these questions? Because in final exam you will get question on this for 8 marks. समजलाय का हा क्वेश्चन? का रिपीट करायचा आहे?
Repeat.
Okay. Which point do you want to repeat? For which sub questions?
Second.
Second, that is M of R converse.
Yes, ma'am.
Okay. So how to find this R converse? Just you have to interchange rows and columns. So M of R is given. So M of R, if you observe this, first row is 101. So in order to obtain its converse, you have to consider this 101 as first column. Row आहे त्याचं कन्वर्जन कॉलम मध्ये करायचं आहे, कॉलमचं कन्वर्जन रोज मध्ये करायचं आहे. सो फर्स्ट रो, this becomes first column in M of R converse. That's why I have taken here 101. First row होता त्याला आपण first column केलं. Now second row is 110. Now that becomes second column in M of R converse. And then 111, this is the third row. So now it will be third column in M of R converse. This is the value for M of R converse. समजलं का? फक्त रोज एंड कॉलम्स इंटरचेंज करायचे.
Yes, ma'am.
Okay. Okay. Again some formulas are given here. That is R of converse converse. This is equals to R that we have seen. Then if R is equals to S, then this is equivalent to R converse is equals to S converse. Again, if R is subset of S, then this is equivalent to R converse is subset of S converse. Again, R of R union, that is unionचा negation है, R union negation S, this is equivalent to R negation union S negation. Just we have distributed this negation over R and S. So likewise R intersection negation S, this is equivalent to R negation intersection S negation. So these are the some formulas. So take note of these formulas. Now next important point is a composition. How to find composition of relations. Okay. So let R be a relation from X to Y and S be a relation from Y to Z, then relation written as R composition S. So this is the symbol for composition. This composition is between two relations R and S. That's why R composition S is called a composite relation of R and S. Okay. So suppose here that is given R is a relation from X to Y and S is a relation from Y to Z. Then composite relation R composition S, that will be from X to Z. That's why X to Z, that will be a composite relation between R and S. Then how to find composition is given. Suppose consider first example, R and S are given, okay, and we have to find R composition S. Now first of all we have to check first order pair in relation R, and that order pair is 1, 2. Now in relation S we have to find such a order pair whose first element is 2. Now look at relation S. There is one order pair 2, 5 whose first element is 2. Okay. Now this 1, 2 and 2, 5. So this 2, 2 will get cancelled. You will get order pair as 1, 5. So this is the first order pair in R composition S. Okay. Now again you have to observe which one is a second order pair in relation R, and that is 3, 4. So now we have to find such a order pair in relation S whose first element is 4, and there is one order pair 4, 2. That's why this 4, 4 will get cancelled. You will get order pair 3, 2. So that is the second order pair in R composition S. Now third order pair in relation R is 2, 2. So again we have to observe such a order pair in relation S whose first element is 2, and there is one order pair 2, 5. So again these two will get cancelled. You will get order pair 2, 5, and this is the last order pair in R composition S. So in this way we can find composition of relations. So first of all tell me, have you understood how to find composition? Just one point we have seen, R composition is. Still we have to find all these compositions.
Ma'am, repeat once again.
So first of all understood what is the meaning of composition. Now suppose there are two relations R and S. Okay. So relation R is from set X to set Y and relation S is from set Y to set Z. So whenever we have to find composition between these two relations, then we will get one relation, and that relation will be from X to Z. That's why R composition S is written as from set X to set Z. Okay. Now here in the first example, two relations are given, R and S, and first value we have to find as R composition S. Okay. So what is the rule to find this composition? We have to observe first order pair in relation R, because we have to take composition between R and S. If we have to take composition between S and R, then we have to first consider order pairs from relation S. But here first relation is R. That's why we have to start with order pairs of relation R. Now observe what is the order pair of relation R. So first order pair is 1, 2. So here second element of this order pair is 2. So we have to find such a order pair in relation S whose first element is 2. आता चेक करा, आपल्याला अशी ऑर्डर पेअर फाइंड करायची आहे ज्याचा फर्स्ट एलिमेंट 2 असला पाहिजे. So first one is 4, 2, that is not useful. Second order pair is 2, 5. So here first element is 2. So now these two and these two will get cancelled. You will get order pair as 1, 5. So that is the first order pair in R composition S. Okay. Now again check whether there is any another order pair whose first element is 2. No, there is no such order pair. That's why we are going to switch towards the next order pair, and that order pair is 3, 4. Now here second element is 4. That's why we have to find such a element or such a order pair in relation S whose first element is 4. So that order pair is 4, 2. That's why this 4 will get cancelled. You will get answer as 3, 2. So that order pair is included in R composition S. So again check whether there is any another order pair whose first element is 4. No, there is no such order pair. So we can say that the processing for this order pair 3, 4 is over. So we can move to the next order pair, and that order pair is 2, 2. So again we have to find such a order pair in relation S whose first element is 2, and that element is 2, 5. Okay. So here that order pair is 2, 2. Here it is 2, 5. So again these two and these two will get cancelled. You will get order pair as 2, 5. So that is written as third order pair in R composition S. Now check whether there is any another order pair in relation R whose processing is remaining. No, only 3 order pairs were there, and we have processed all these 3 order pairs. That's why answer for R composition S is set of order pairs. First order pair is 1, 5, 3, 2 and 2, 5. Understood now?
Yes, ma'am.
Yes, ma'am.
So likewise we have to find S composition R. Now here relation S is the first relation. So first of all we have to consider order pairs from relation S. Now first order pair in relation S is 4, 2. So now we have to observe such a order pair in relation R whose first element is 2. 4, 2 आहे म्हणजे ह्या ऑर्डर पेअरचा सेकंड एलिमेंट काय झाला 2. सो नाउ वी हैव टू फाइंड such a order pair in relation R whose first element is 2, and that order pair is 2, 2. So again these two will get cancelled. You will get answer as 4, 2. So that order pair is included here in S composition R as 4, 2. Okay. So now next order pair from relation S is 2, 5. So now we have to find such a order pair in relation R whose first element is 5. Now check the relation R whether there is any order pair whose first element is 5. No, there is no such a order pair. That's why we are going to skip this order pair 2, 5. Now move to the next order pair, and that order pair is 3, 1. Now we have to observe such a order pair in relation R whose first element is 1 S and there is order pair 1, 2. So again 3, 1, 1, 2, this 1, 1 will get cancelled. You will get order pair 3, 2 and that order pair is included here in S composition R. Now move to the next element. That order pair is 1, 3 and now we have to observe such order pair in relation R whose first element is 3 and that order pair is 3, 4. So again these three will get cancelled. You will get order pair as 1, 4 and that is given here as last order pair from S composition R 1, 4. So now check whether R composition is and S composition are same. No.
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 Both the compositions are having different order pairs. That's why we can say that S composition R, this is not equals to R composition S. Okay. So in this way we can find composition of relations. Have we understood first 2 points? R composition S and S composition R. Okay. Now next point you have to find R composition R and S composition S. So find these two compositions, then we will see how to find composition between three relations. So first of all find the value for R composition R. Now here both the relations are same, that is we have to take composition of relation R with R itself. So you have to consider relation R twice. Take 2 minutes and find what is the value for R composition R.
Order pair 1, 2 and order pair 2, 2.
For R composition R 1, 2 and 2, 2 is
2.
correct. Yeah. And what is the value for S composition S?
Order pair 4, 5, order pair 3, 3 and order pair 1, 1.
Is correct. Order pair 4, 5, 3, 3 and 1, 1. Okay. Now we have to solve the next point as what is the value for R composition in bracket S composition R. Okay. Now already we are with values S composition R. S composition R आपल्याला माहिती आहे. R relation R is given. So now we have to find composition of this relation R with S composition R. Okay. Now first see what is the order pair in relation R and that order pair is 1, 2. So now we have to find such a order pair in S composition R whose first element is 2. Now check whether there is any order pair whose first element is 2. No, there is no such a order pair. So now move to the next order pair and that order pair is 3, 4. Now we have to find such a order pair in S composition R whose first element is 4 and that order pair is 4 comma 2. So again this 4 4 will get cancelled. You will get order pair as 3 comma 2. Okay. So that is written here 3 comma 2. Now move to the next order pair, that is 2 comma 2. Now check whether there is any order pair whose first element is 2 in S composition R. No, there is no such order pair. That's why value for R composition S composition R, this is equals to order pair 3 comma 2. Now we have to find the value for R composition is composition R. Now R composition is, we have already find out. Now we have to take its composition with R. Okay. So first we have to consider first order pair in R composition is, and that order pair is 1 comma 5. Now we have to check in relation R whose first element is 5. No, there is no such order pair in relation R whose first element is 5. That's why we are going to skip this order pair. Now move to the next order pair, that is 3 comma 2. Now we have to find such order pair in relation R whose first element is 2 and that order pair is 2 comma 2. So 3 comma 2, 2 comma 2. Again this 2 2 will get cancelled. You will get answer as 3 comma 2 and that is written here. Now check for the next order pair in R composition is, and that is order pair 2 comma 5. Now check in relation R whether there is any order pair whose first element is 5. No, there is no such a order pair. That's why we are going to skip this order pair. So value for R composition is composition R, this is equals to order pair 3 comma 2. Now check for the results of R composition S composition R and R composition S composition R. Both are containing same order pair as 3 comma 2. That's why we can say that this composition operation is a associative operation. That is, in bracket R composition S composition P, this is equals to R composition in bracket S composition P, and this is equals to R composition S composition P. So keep in mind that this composition relation is a associative relation, but this is not a commutative relation. That's why R composition S, this is not equals to S composition R. So only one property is satisfied by this composition relation, and that is associative property. So have you understood this problem? Hello?
Yes, ma'am.
Okay. Now just one composition is remaining, that is R composition, R composition, R. So find the value for this composition. We have already solved the value for R composition R. Now take its composition with relation R. So you will get R composition, R composition, R.
Order pair 1 comma 2 and 2 comma 2.
Yes, correct. Order pair 1 comma 2 and 2 comma 2. So in this way we can find composition between any number of relations. Okay. Now see the next example. Let relation Rn is with the two relations on set of positive integers I. Okay. And R is defined as set of order pairs x comma 2x such that x belongs to I, and S is equals to set of order pair x comma 7x such that x belongs to I. Okay. Then find R composition S, R composition R, R composition R composition R, and R composition S, composition R. Okay. So one by one we will solve it. First is R composition S. Now order pair for this R is x comma 2x. Now we have to find order pair in relation S such that the first element of that order pair should be 2x. आता इथे आर मध्ये सेकंड इलेमेंट काय आहे 2x आहे व एस मध्ये आपल्याला असा इलेमेंट पाहिजे किंवा अशी ऑर्डर पेअर पाहिजे ज्याचं फर्स्ट इलेमेंट 2x असेल बट हियर that order pair is x comma 7x. So how we can make this 2x? So we have to multiply this order pair by 2. That's why now first element becomes 2x and second element becomes 14x because we have multiplied this order pair by 2. Now again this 2x and 2x will get cancelled. You will get answer as x comma 14x for any x belongs to I. काय केलंय समजलं का?
Yes, ma'am.
Okay. Now next we have to find R composition R. आता R काय दिलं आपलं relation R is x comma 2x. Now again we have to take its composition with R only. So again R becomes x comma 2x. Now this 2x we need to find in a first element of second order pair. आता x comma 2x x comma 2x हे दोन order pair झाले. So first order pair second element is 2x. So we have to multiply second order pair by 2. So that becomes 2x comma 4x. So 2x will get cancelled. You will get x comma 4x. So that is value for R composition R. काय केलं समजलं का? You have to write a relation
Yes, ma'am.
R 2 times and second element of this order pair is 2x. That's why for this second order pair you have to multiply that order pair by 2. So 2x comma 4x. So 2x will get cancelled. You will get answer as x comma 4x. So likewise find the values for R composition R and R composition S composition R. So first tell me what is the value for R composition R.
x comma 8x.
Yes, 8x.
Yes, x comma 8x. Correct. And last value?
x comma 28x.
Yes, x comma 28x. Correct. Okay. So for the relations R and S given in example 1 over the set 1 to 5, obtain the relation matrices for R composition S and S composition R. Okay. So here the matrix for relation R and S are given. From that we have to find matrix for R composition S and S composition R. So again we have to perform matrix multiplication here. So matrix for MR is given, matrix for S is given. So first consider the first row of MR and then multiply it by first column. काय व्हॅल्यू येणार आहे 0 into 0 0 1 into 0 0 0 into 1 0 0 0 0 0. Means what? First value for R composition and R composition S matrix it is 0. Again first row second column. So observe it. You will get value as 0 only. Again first row third column. So its value is 0. Then first row fourth column 0 and first row last column it is 1 because 0 into 0, 0, 1 into 1, 1. So 0 plus 1, you will get final value as 1. So likewise, now consider second row 0, 1, 0, 0, 0 and first column 0, 0, 1, 0, 0. So you will get value as 0 only. Then second row, second column, again it is 0. Then second row, third column 0. Then second row, fourth column 0 and second row, last column it is 1. So likewise you have to perform matrix multiplication. So you will get matrix for R composition S. Now again they have asked us to find the matrix for S composition R. So can anybody tell me how to find matrix for S composition R? So when we had to find the matrix for R composition S, we have taken matrix multiplication of R and S. So now we have to take matrix multiplication of matrix of S and matrix of R. So you will get matrix for S composition R. R composition S find करायचं होतं. That's why we have taken matrix of R first, then matrix of S. Now here we have to find matrix for S composition R. That's why we have to take matrix of S first, then matrix of R. And just you have to perform matrix multiplication. Have we understood this question?
Yes, ma'am.
Okay. So here we have to find some examples based on composition of relations. Relation R, relation S, these two relations are given, and from these two relations we have to find R composition S, S composition R, R composition S composition R, R composition S composition R, R composition R, S composition S, and S composition S composition S. Okay. So first tell me what is the answer for R composition S. Now first order pair in relation R is 1, 1. So now we have to find such order pair in relation S whose first element is 1 and that order pair is 1, 1. So again this one will get cancelled. You will get final order pair as 1, 1 and that is written over here. Now next order pair is again 1, 1, 1, 4. So this one will get cancelled. You will get order pair as 1, 4. Okay. Now second order pair in relation R is 1, 2. So now you have to observe such order pair in relation S whose first order pair is or first element is 2. So that order pair is 2, 3 and 2, 4. Two order pairs are there. So again these two will get cancelled. You will get answer as 1, 3. Again these two will get cancelled. You will get order pair as 1, 4. Now next order pair is 2, 3. So we have to observe such order pair in relation S whose first element is 3. So 2, 3 and 3, 1. So 3, 3 will get cancelled. You will get answer as 2 comma 3. Sorry, 2 comma 1. Now next one is 2 comma 4. So we have to find such order pair whose first element is 4 and that order pair is 4 comma 4. So this 4 will get cancelled. You will get answer as 2 comma 4. Then next one is 3 comma 4. So again 3 comma 4, 4 comma 4. 4 will get cancelled. You will get 3 comma 4. Then next one is 4 comma 1. So 4 comma 1 comma 1 comma 1. So 1 will get cancelled. You will get 4 comma 1. Again for this one there is another order pair 1 comma 4. So again 1 will get cancelled. You will get 4 comma 4. And last one is 4 comma 2. So again 4 comma 2 and 2 comma 3. 2 will get cancelled. 4 comma 3 and again 4 comma 2, 2 comma 4. So 2 will get cancelled. You will get 4 comma 4. So in this way you can find the composition of R and S. Now remaining points you have to solve. So next one is S composition R. So solve this all questions and tell me answer within 10 minutes. So you have to find value for S composition R composition S composition R composition S composition R composition R, S composition S and S composition S composition S. So take 10 minutes and solve all these questions. Hello. Have we solved it?
Solving, ma'am.
Okay. Hello. So, what is the answer for S composition R?
Order pair 3 comma 1, 3 comma 2,
Okay. Next.
4 comma 1, 4 comma 2,
Hmm.
2 comma 4,
Okay.
1 comma 1, 1 comma 2,
1 comma 1, 1 comma 2. Yes, that is covered. Next.
2, 2 comma 1, 2 comma 2.
2 comma 1, 2 comma 2. And 4 comma 1, 4 comma 2.
It is taken, ma'am.
Okay.
Yes, ma'am.
Okay. Good. So, next one is R composition R. So, what is the answer for R composition R? Check it. 1 comma 1, 1 comma 2, 1 comma 3,
1,
1 comma
2,
4.
1.
Hello? 2 comma 4, 2 comma 1, 2 comma 2, 3 comma 1, 3 comma 2, 4 comma 1, 4 comma 2, 4 comma 3 and 4 comma 4. Have we got same answer?
Yes, ma'am.
Okay. Now next one is S composition is. So tell me what is your answer for S composition is? सॉल्व केले का?
3 comma 1,
ओके 2 comma 1,
3 comma 1, 3 comma 4, 2 comma 1, 2
comma
comma 4, and 1 comma 4.
1 comma 4 and 1 comma 1. Is it there 1 comma 1?
No, ma'am.
No, you should take, because here in this relation is order pair 1 comma n 1. Now we have to take its composition with again s. So second s will be having 1 comma 1. So 1 comma 1, 1 comma 1, 1 1 gets cancelled. You will get 1 comma 1. So you must include this order pair 1 comma 1 in this composition, and 4 comma 4 is also there, because here S is containing 4 comma 4. So again second S will contain 4 comma 4. So 4 4 will get cancelled. You will get 4 comma 4. So don't forget to add these two order pairs. Now next one is R composition, S composition R.
2 comma 1, 2 comma 2, 2 comma 1, 2 comma 2, 3 comma 1, 3 comma 2, 4 comma 2, 4 comma 1, 4 comma 4, 4 comma 1, 4 comma 2, 4 comma 1.
रिपिटेशन शुड नॉट बी देअर. जर एखादी ऑर्डर पेअर रिपीट झाली असेल, लाईक 4,1, 4,1, देन यू हॅव टू कन्सिडर दॅट वन ॲज ओनली वन ऑर्डर पेअर. एकदाच लिहायची त्या कंपोजिशनमध्ये. ओके. अँड लास्ट वन इज आर कंपोजिशन इज कंपोजिशन आर.
1 comma 1, 1 comma 2, 1 comma 4, 2 comma 1, 2 comma 2, 2 comma 3 comma 1, 3 comma 2, 4 comma 1, 4 comma 2, 4 comma 1.
अगेन 4,1. सो रिपिटेशन नको आहे तिथे. रिपीट झाली तर एकदाच कन्सिडर करा. नाउ जस्ट टेल मी वेदर आन्सर फॉर आर कंपोजिशन एस कंपोजिशन आर अँड आर कंपोजिशन एस कंपोजिशन आर इज सेम.
Yes, ma'am.
Okay. So again,
Yes,
this
ma'am.
is satisfying associative property. So result for these two should be same. And last one is S composition, S composition S. So what is the answer for this composition?
3 comma 1, 3 comma 4,
2 comma 1, 3 comma 4. Okay. Next.
Madam, screen is not visible.
I think someone is presenting. Just a minute. Hello? Is it visible now?
Yes, ma'am.
Okay. So what is the answer for this composition? Last one?
3 comma 1, 3 comma 4, 2 comma 1, 2
Hmm.
comma 4, 1 comma 4, 1 comma 1, and 4 comma 4.
Okay. So second question. In this question, the matrices for relation R and S given. Then we have to find composition for matrix of R and matrix of S. So first of all, tell me how we can solve this kind of problem. What we have to done?
Matrix multiplication.
Yes, matrix multiplication. Now M of R. This is 3 by 5 and M of S is 5 by 4. So your resultant matrix will be of
5 by 4.
5 by 4. No. First one is 3 by 5. Second one is 5 by 4. So your resultant matrix will be of 3 by 4. Okay. So find matrix multiplication for these two matrices and tell me your final answer for this composition. Take 5 minutes and solve this question.
First column is 1, 1, 1.
Okay. Next,
Ma'am, screen is not visible.
again someone is presenting. Please don't present anything. Okay. So second column
1, 1, 0,
110. Third one is
1, 0, 1,
101 and last one.
1, 1, 0.
Yes, that is correct. Next question. Here three sets are given ABC and over these three sets a relation R and S are defined. So R and S are given here. We have to find value for S composition R. So tell me what is the value for this composition?
Null set.
null set S 5 because there is no such order pair for S composition R. Correct. Question number 4. Let set A is equals to A comma B, R is equals to set of order pairs as A comma B, B comma A, B comma B, and S is equals to A comma A, B comma A, B comma B. Then find S composition R and R composition S.
Hello, ma'am.
Hello? Yes? Have you solved?
Yes, ma'am.
Yes, ma'am.
Yes. So what is the answer for S composition R?
A comma B, B comma B, B comma A, B comma B.
Okay. And for R composition S?
A comma A, B comma A comma B, B comma B.
A comma A comma B, B comma A, and B comma B. Correct. Next question. Given the relation matrix M of R of relation R on set ABC, find relation matrices of R converse R square. R square means what? R composition R. R cube and R composition R converse. So here matrix for relation R is given. Here M of R. From that we have to find what is the matrix for R converse, matrix for R square, matrix for R cube, and matrix for R composition R converse. So first of all you have to find the matrix for R converse. So what would be the first row for R converse? So first of all tell me how we can find the matrix for R converse from M of R. What is the procedure? What we have seen?
Interchange row and column.
Yes, just we have to interchange rows and columns. Now here 101, this is the first row. So it will become first column for matrix of R converse like 101. Then 110, this becomes second column 110, and 111, this is the last column. Now find the matrix for R square. So what is meaning of R square? This is equals to R composition R. Now matrix for relation R is given. Now take its multiplication with again matrix of R. So it will give you matrix for R square. काय ते बघा you have to take multiplication of two matrices, that is M of R multiplication M of R.
First column is 1 1 1.
First column is 1 1 1. Okay.
Second column 1
Second
1
one
1. Third column 1 1 1.
and third one is also 1 1 1. So this is the first method to obtain matrix for this composition. Second method is here matrix for relation R is 1 0 1 1 1 0 triple 1. So here we can find or we can define relation R from this matrix. Now this matrix is of 3 by 3, 1 2 3 1 2 3 rows and columns. Okay. Now first one is here. This one represents that this order pair is present in relation R. So we can define relation R as first order pair is 1 comma 1. Now here 0 is written, means what? Order pair 1 comma 2 is not there. Now again 1 is written here, so order pair 1 comma 3 is included in relation. Now for this one order pair 2 comma 1. Now for this one order pair 2 comma 2. So 0 means what? This order pair is not included. Now for the third row 1 is written here. So this means that order pair 3 comma 1 is there, 3 comma 2 is there and 3 comma 3 is there. So in this way we have defined relation R. Now take its composition with R only, because we have to find R square, and R square is equals to R composition R. Now tell me what is the answer for R composition R? Yes, have you solved? What is the value for R composition R? Hello.
Yes, ma'am.
So what is the value for R composition R?
1 1 1 3 1 2 2 1 2 3 3 1 3 3 3 2.
Yes, correct. So here is the value for R composition R. Now 1 comma 1, 1 comma 2, 1 comma 3. So 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 1, 3 comma 2, 3 comma 3. Means what? Again, for all the places here in 3 by 3 matrix, for all the places 1 is there. Means what? That order pair is present in the relation. So in the both the way you can solve the example. Method 1 is for matrix multiplication. Method 2 for given matrix you can define relation and then you can take composition of relation. So which method is compatible for you? Which one is easy? First or second? कुठली प्रेफर करायची आपण मॅट्रिक्स मल्टिप्लिकेशन का रिलेशन डिफाइन करायचे?
मॅम सेकंड मेथड एक्सप्लेन करा अजून एकदा.
सेकंड. ओके.
येस मॅम.
हॅलो. Hello. Hello.
Yes, ma'am.
Okay. So for this second method, for this matrix, given matrix, we have to define relation R. Now this matrix is of 3 by 3. So we can numbers the rows as 1, 2, 3 and columns as 1, 2, 3. So now this is our matrix. So we have written here 1. 1 means what? That order pair is present in given relation like 1 comma 1. But we cannot include this order pair 1 comma 2 here because we have written 0. 0 means what? Absence of that value. Now again 1 is there means what? Order pair 1 comma 3 is there in relation R. So likewise 2 comma 1, 2 comma 2 we can include, but order pair 2 comma 3 we cannot. Then for third row 3, 1, 3, 2 and 3, 3 we can include. Now we have find just relation R. Now in order to find R square, we have to take R composition R. Now value for this R composition R is order pair 1, 1, 1, 3, 1, 2, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. Means what? Again from this R composition R we can find a matrix, and that matrix is 1, 1, 1, 1, 1, 1, 1, 1, 1. So in this way we can find R square, that is R composition R. फर्स्ट मेथडमध्ये काय केलं, मॅट्रिक्स मल्टिप्लिकेशन फाइंड केलं आणि त्याच्यावरून रिलेशन डिफाइन केलं. सेकंडमध्ये दिलेल्या मॅट्रिक्सवरून रिलेशन डिफाइन केलं आणि त्याच्यावरून कंपोजिशन काढलं. सो इन दी बोथ दी वे यू कॅन सॉल्व दिस एक्झाम्पल. हॅव यू अंडरस्टूड इट?
Yes, ma'am. Yes, ma'am.
Okay. So today we are going to stop here. Give present in. Relation. Okay. So in this relation topic we have seen what is the relation, then what are the properties of relation, then converse of relation, composition of relation, then how to find matrix of given relation and how to find matrix for composition of relation. Only few points are remaining and those points we will cover in the next lecture. Present please. Roll number 1.
Yes, ma'am.
Roll number 2. 3.
Yes, ma'am.
4.
Yes, ma'am.
5. 6.
Present, ma'am.
7.
Present, ma'am.
8.
Ma'am.
Yes.
Present. Hello, ma'am.
Yes, who is there?
To roll number, ma'am. Microphone is not working, ma'am.
Okay. Roll number
On
7.
that time.
Okay. Roll number 7.
Present.
8.
Present, ma'am.
9. 10.
Present, ma'am.
11.
Present, ma'am.
Okay, 11 is present. 12. 13.
Yes, ma'am.
14.
Yes, ma'am.
15.
Present.
16.
Yes, ma'am.
17.
Present, ma'am.
18.
Present, ma'am.
19. 20. 21.
Yes, ma'am.
22.
Present, ma'am.
23.
Present, ma'am.
24.
Present, ma'am.
25.
Yes, ma'am.
26.
Yes, madam.
27.
Present, ma'am.
28. 29.
Yes, ma'am.
30.
Present, ma'am.
31. 32. 33.
Present, ma'am. Present, ma'am.
34.
Present, ma'am.
35. 36. 37.
Present, ma'am.
38.
Present.
39,
Present, ma'am.
40,
Present, ma'am.
41, 42, 43, 44,
Yes, ma'am.
45,
Yes, ma'am.
46, 47,
Yes, madam.
48,
Yes, ma'am.
49,
Present, ma'am.
50,
Yes, ma'am.
51,
Present, ma'am.
52, 53,
Yes, ma'am.
54,
Yes, ma'am.
55, 56,
Yes, ma'am.
okay, 57,
Yes, ma'am.
58,
Yes, ma'am.
59,
Yes, ma'am.
60, 61,
Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64, 65,
Present, ma'am.
66,
Present, ma'am.
67,
Yes, ma'am.
68, 69,
Present, ma'am.
70, so today's absent numbers, roll number 5, 9, 12 is
70.
7, is 7 is present,
12 is present, sir.
12, okay.
19 is present, ma'am.
Hmm. Hello,
28 present, ma'am.
20,
Roll number
8,
90 is present, ma'am.
19,
8.
okay. Any another number?
Roll number 28.
Is 28.
70.
Okay. Hmm. Or
7.
19.
is 19 already taken?
Ma'am, can you tell option numbers?
Roll number 5, 9,
70.
20, 31, 35, 36, 41, 42, 43, 46, 52, 55, 60, 64, 66, and 68.
I'm 9 present.
Okay. Okay, so today we are going to stop here. Remaining points we will see next lecture. Thank you.
Hello, ma'am.